Well, howdy there, Internet students. It's Mr. Hermanson again. Hey, we're going to spend one more day on point slope form, learning how to apply it to solve some problems. So this is actually the last problem you had on your assignment from yesterday, but I'd just like to go over it and point out a couple things about using point slope form. Now this one says model the table in slope intercept form. So we're going to actually use point slope form and then change it into slope intercept form. What I need to do first is find the slope. Now these numbers here are going down by 12 and the x values are going up by 1, which means the slope is negative 12. So I'm going to then just pick a point from these, and it doesn't really matter which point you use. I'll just pick these because they're really simple little numbers. But so this is my y sub 1 and this is my x sub 1 when I substitute into the equation. So now I'm going to put y minus 8 equals negative 12 times the quantity x minus 6. Okay, and we want it in slope intercept form because that's just a simpler form. To do that, let's get rid of the parentheses over here. So let's multiply by 12, and then we get negative 12x plus 72. And then the last step would be add 8 to both sides, and we get y equals negative 12x plus 80. Okay, which means my y-intercept is 80. So if I went back to 0 here, this would be 80. All right, so I have that equation now in slope-intercept form. And this was a situation that dealt with the volume of paint decreasing as your days go up, which makes sense. The more you paint, the less you have. So you can keep an eye on your paint supplies. So what we're going to do is just look at some different problems that it makes sense to use the point slope form. Okay, so if you have 2 points, so I'm going to let my x be my hours and my y be how much I earn here. So Justin gets an hourly wage plus tips. So last week he got $130 for working 5 hours. That would be 1 point. So 5 hours, $130. And then on a week that he worked 11 hours, he got $175. So there's your 2 points. Let's find the slope with those first. So the slope would be 175 minus 130 over 11 minus 5. So basically between those we can see that for an increase of from 175 to 130, which is $55 increase, he worked 6 hours. Little math error there. This should be 45 divided by 6, which is 750, which means he gets 750 per hour. Okay, so now if I write that in point slope form, I just need to pick one of these 2 points. I'll pick this one and do y minus 130 equals 7.5 times x minus 5. And then if I want to put that in a simpler form, slope-intercept form, all I have to do is distribute the 7.5, so 7.5x minus 3750, that's 7.5 times 5, and then add 130 to both sides. And we end up with 92.5. So basically he gets 92.5 in tips and then plus 750 an hour. Okay, so I just kind of explained that. This is the initial amount he would get just for working, and then this is his hourly wage. So now if we want to figure out how much he gets for 16 hours a week, this slope-intercept form works a lot better for that. We would just take 7.5 times 16 plus 92.5. And that equals 212.50. All right, let's try another one. I'll see if you can do it. I'll just kind of get you started, get you the points, and then you can try and write the equation. First write it in point slope and then simplify it to slope intercept form. So Austin is a pilot. He contacts air traffic controller, knows okay to descend and land. 5 seconds after contacting the air traffic controller, his altitude is 1,800 feet. So let's write that point. 20 seconds, he's at 1,350 feet. So go ahead and find the slope and write the equation in point slope form. And then change that by simplifying it to slope intercept form. All right, so here's the equation you should have got. If you didn't get that, check and see where your mistake is. This negative 30 means he's descending at a rate of 30 feet per minute. And this is the initial altitude that he was flying at, 1,950 feet. And so our question is, how long after Austin's first contact with the air traffic controller does he land? So he's decreasing at a rate of 30 feet per minute, and he started at an altitude at 1950. We need a value that we can substitute in. And when you land, your altitude is actually 0. And that would be your y coordinate here. So to solve this, you're going to put 0 where that y coordinate is, and then figure out what x is, which is how many seconds it takes to get there, or how many minutes, whatever it is, the amount of time. Okay, so go ahead and solve that. When you solve it, you would subtract 1950, which would make this a negative 1950 over here. And then you would divide that by negative 30, which would make it a positive number. And if you did it right, you should have got 65 seconds to land. All right, that's all I got for you. Go ahead and do the Google form. You're going to have to print out this worksheet in order to have it by your side while you do it. Otherwise, just put it on scrap paper. Let me know if you have any questions.